Hi everyone, welcome back to Life Technologies YouTube channel and thank you for watching. So just a reminder that if you are watching this episode and you are yet to subscribe to our channel, kindly hit that subscribe button to support our channel and to also stay tuned for more upcoming videos. So we are continuing with our Nokia Lab simulation. Remember, in this series, we demonstrate how to configure or how to implement different networking technologies or different networking protocols on Nokia routing and switching devices. So in this episode, we will be focusing on how to implement a VPLS, that is a Virtual Private Lan Service on Nokia routing devices. So in our previous episode, we have also discussed how to implement ePipe, that is a VPWS, a Virtual Private Wire Service that only supports a point-to-point connection. So they are both layer 2 VPN, but a VPWS only supports a point-to-point connection. The good advantage of VPLS is that it supports a point-to-multipoint connection. And both VPLS and VPWS are commonly used to deploy the enterprise services on service provider networks. So you have customers connected to different PEs in our MPLS backbone, and you need to provision services for them. So you have to use layer 2 VPNs like the VPWS or VPLS and deploy layer 2 VPN on the service provider network. So the service from the customer will be transparently transported over our MPLS backbone network. So you can see that in this setup, we have three sites. We have site 1, site 2, and site 3. They are connected to our MPLS backbone network. This is the service provider network to different PEs. So we have PE1, PE2, and PE3. So we need to provision a VPLS service for this customer. So the customer has 3 branches and the requirement is that there should be communication between the branches. So we need to deploy a VPLS, a layer 2 VPN for the customer so that they can achieve connectivity between different sites. So in one of our previous episodes, I've said we have demonstrated how to configure an ePipe, a point-to-point layer 2 VPN. So you can check it out on our channel and learn how to configure a VPWS or an ePipe on Nokia routing devices. So you can see from the topology, we have our MPLS backbone and we are running OSPF at the IGP for connectivity between the PEs. So we have P1, P2, and P3. They are all interconnected. And then we have site 1 connecting to P1, we have site 2 connecting to P2, and we have site 3 connecting to P3. So we have planned the IP address as shown. We have the system IP. So we have 1.1.1.1/32 for P1, 2.2.2/32 for P2, and 3.3.3/32 for P3. And we also have point-to-point connection, and we have IP addresses assigned for the sites. So the 3 sites are in the same subnet, so we need to ensure that we have connectivity between the 3 sites over our MPLS backbone network. So for the configuration stages, of course, we need to ensure there is reachability between nodes in our MPLS backbone. So we are configuring OSPF on our network. So the first step of our configuration will be to configure interfaces. We need to ensure that we have interface configured, that is the point-to-point interface between different routers. And we also need to ensure that the system interface is assigned with an IP address. Once we have point-to-point IP address configured, we'll move forward and configure the OSPF protocol. And we also need to implement LDP and MPLS. Remember, this is the MPLS backbone, so we need to configure MPLS and LDP. And once we have implemented MPLS and LDP, we can now go ahead and configure the VPLS on the network. So the first stage of our configuration, we'll do the configuration step by step so that we get familiar and we are able to see each and every detailed step of configuration for the VPLS. So starting from here, we can start by configuring the sysname for the nodes. So we'll start with R1. So R1 is our P1. So we are still using the same command, configure system name. We call it P01. And then we have router 2. So router 2, we do the same, configure system name P02. And then finally router 3, configure system name PE03. We also need to assign names for our sites, so we start with R4, R5, that is. So R5, it's, let's see, show system LLDP neighbor. R5 is connecting to PE2. PE2 is site 2, so it's, this one will be configure system name site 2. And R4 is our site 1, show system LLDP neighbor is connecting to P1, so configure system name. And this is site 1. And then finally we have R6. We do the same, configure system name site 3. So we have done configuration for our site names. So the next stage is now to verify the link connecting different routers. And we have demonstrated this before. So you can use show system LLDP neighbor. You can see that we have 3 connections. We have connection to P1, P2, P2, P3, and site 1. On R2, we can verify the same, show system LLDP neighbor. We have connection to P1, P2, P3, and site 2. On R3, we can also verify that we have show system LLDP neighbor. We have 3 connections to P1, P2, and site 3. So our physical links are up, and we need to start doing the configurations. So for the configuration, we'll start by configuring the interface IPs. If I run the command, let's start with R1, shows router interface. You can see that we only have the system interface, but it doesn't have any IP assigned. So we need to configure IP address on this system interface and also configure the point-to-point IPs between the different routers. So on P1, we'll configure router interface system. Once you are in this interface system, you can go ahead and configure the IP address. Its mask is 32. So now if I show router interface, you can see that an IP address has been assigned to this system interface. We can go ahead and configure the interface to R2 and R3. So configure router. I hope you are able to see the topology. This is the topology that we are using. Let me move it slightly up. So configure, let me just start again, configure router. We are configuring interface to R1. Once we are in this interface, we need to first, we can give it a description. Now this is, we don't need this interface. This is a wrong interface. So to undo an interface is configure router, no interface to R1. We need to shut down the interface, so I can shut down the interface to R1 shut down, then I can recall the same command. So on P1 we are configuring interface to P2 and P3. So I will configure router. I'll go into this hierarchy and then we can start our interface configuration, interface to P01, P02, we are on P01 already. And then we need to give an address of 10.10.10.0, mask is 31. We can give it a description to P02. And we need to give the port. So if I show system LLDP neighbor, you can see that this C1 is the one connecting to P2. So I can do port and copy this port. So if I do info, you can see that we have an address assigned, we have description, and we have the port. So exit, we can configure another interface to PE03, description to PE03. We give it an address of 10.10.10.2, mask is 31. info, then we need to give it a port. So can do again show system LLDP neighbor to see the port connection, and I take the port connecting to P3. Display info, exit. We can check the configuration for our interfaces. So these are the configuration for the interfaces. We have interface to P2, we have interface to P3, and then we have the system interface. So these are the interface configuration that we need on our P1. We can go ahead and configure P2, show system LLDP neighbor. We have the 3 connections. So on P2, we'll start by configuring the system interface. Configure router interface system. We assign address directly. Address it's 2.2.2, mask is 32. And then we can go ahead and configure the other interfaces. So I will go into the router configuration hierarchy. I can do interface to PE01. We can give it a description to PE01, then an address of 10.10.10.1, mask is 31, and we need to give it to assign the port. So the port to P1 is this one, info. So we have finished configuring the interface to P1. We need also to configure interface to P3. P03 description to P03, can give it an address of 10.10.10.4, mask is 31, give it the port. We'll again show system LLDP neighbor to verify the port. So this is port to P3, it's C2. Info, exit. So from here you can see that we have the configurations. Let me see, info. So we have the configuration to interface to P1, to P3, and to system. So that is it for R2. We can do the configuration for R3. So same, we'll configure the system interface, configure router interface system. Address, we can give it 3.3.3, 32. And then we need to configure the interfaces going to P1 and P2. I will go into the configure router hierarchy, and then interface to P1. Description, it's always good to give our interfaces good description. It's the interface to P1. I need to give it an address of 10.10.10.3, mask is 31, and then I will do the port, so show system LLDP neighbor. We need the port to P1, so that is it, exit. I need to configure another interface to P2, to P02, give it a description to P02, give it an address of 10.10.10.5, mask is 31, and bind the port. So we are binding the port to P2, that is C2. Info, exit, show router interface. We should get the 3 interfaces. Can verify the configurations from here. So we have interface to P1, interface to P2, and the system interface. So we can test whether we are able to ping between the 3 routers. So this one, show router interface on P1. We try to ping 10.10.10.1. We are able to ping 10.10.3. We are also able to ping on P3, show router interface. We try to ping 10.10.10.2. We are able to ping 10.10.4. we are able to ping. So we already have connectivity between the different routers on the point-to-point interfaces. So this one verify that our interface configuration are okay. The next stage of configuration is to now configure OSPF on our routers. So we'll configure OSPF on R1, R2, and R3, and then enable it on the interface connecting the different routers and also on the system interface. So I will start with R1. We are in the configure router hierarchy. We'll configure OSPF process 10. We need to configure the router ID. So router ID will be 1.1.1, the system IP. And we go straight into area 0. Under area 0, we need to enable the interfaces. So I will do interface system, no shutdown. Next, interface to P2, no shutdown, and interface to P3, no shutdown. Exit. We need to unshut down the OSPF process, and then we can check our OSPF configuration. So these are the OSPF configurations on R1. We have the router ID, then we are configuring area 0 and activating OSPF on the interfaces. So we need to do same on R2 and R3. So on R2, we are in this configure router hierarchy. We'll also do OSPF 10, configure the router ID to be 2.2.2. We need area 0, interface system, no shutdown, interface to P1, no shutdown, interface to P3, no shutdown, exit, no shutdown the OSPF process, info. These are the configurations. These are the OSPF configurations on P2. And then we need to do final OSPF configurations on P3. So we'll do OSPF 10, router ID 3.3.3, no shutdown also. We need to unshut down the OSPF process. It's shut down by default. And the next, we need to configure area 0 and finally activate OSPF on interfaces. Interface system, no shutdown. Interface to P1, no shutdown. Interface to P2, no shutdown. Exit, info. These are the OSPF configuration that we have done on P3. So we can verify the OSPF status on the routers, make sure that we are able to reach the system IPs for different routers. So we'll start with router 1, show router OSPF 10 neighbor. You can see that we have 2 peering sessions on this router and they are all in full state. Show router OSPF 10 database. You have the LSS, the router, the network. Show router OSPF 10 routes. You have the routes learned from different systems. Are we able to ping 1.1? Yes, we are able to. We can ping 2.2.2. We are able to. And finally 3.3. We are also able to ping P03 interface. So on R2, we can also verify show router OSPF 10 adjacency, OSPF 10 neighbor. So we have 2 neighboring adjacencies. They are all in full state. The route ID 1.1.1 and 3.3.3. Show router OSPF 10 database. You have the LSS propagated from different routers. Show router OSPF 10 routes. You've learned the routes. You can check the interface. You also have the interfaces configured with OSPF. So remember, we have a different episode that we discuss how to configure OSPF on routers. You can check it out on our channel. On R3, we can also do the same. Show router OSPF 10 neighbor we have two neighboring relationship. They are all in full state. Show router OSPF 10 routes. We have the routes. Are we able to ping this on R3? We can try to ping P2 and try to ping P1. So we are able to, on R2, we didn't check whether we are able to ping. We can ping, this is 1.1. We are able to ping and then ping 3.3. So we have reachability in our MPLS backbone network. So the next stage is now to configure MPLS. So remember, we configure the interfaces. Once you have the interface configured, you need an IGP. It could be OSPF, it could be ISIS, it could be static routes. If you are able to configure static routes, any protocol that you choose to run, depending on your preference or depending on your requirements. So the next stage, I mentioned that we need to now configure MPLS, exit. So we are still under configure router, and then we need MPLS. If you check this, it's shut down, so we need to now shut down the MPLS. So info, it's now not shut down. So you can see that the system interface is always activated in the MPLS hierarchy, so it's already configured. So we need to configure the other interfaces. So I will do interface to RP2, no shut down, then interface to P3, no shut down, info. These are the MPLS configuration that we need on P1. So we'll do the same on P2. So we are in MPLS, we need no shutdown, and then interface to P1, no shutdown, interface to P3, no shutdown. So if you do info, you can see these are the configuration. These are the MPLS configuration that we need to apply on this router. So finally, we do the same on R3, exit. So we are in MPLS configuration view. We need to now shut down, and then interface to P1, no shutdown, interface to P2, no shutdown. Info to verify the configuration. So we have MPLS configured. You can show router MPLS interface. You will get the interface parameters. So once we have implemented MPLS, we need a protocol that will be able to distribute labels in our MPLS backbone. So we are using LDP. So the next stage of configuration is to configure LDP. So how do you configure LDP? It's very easy. Remember, LDP stands for Label Distribution Protocol. So we are using it to distribute the labels, and it will also be our signaling protocol when we are implementing the L2 VPN. So starting with R1, that is P1, we need to be LDP. If you do info, you can see that it's already now shut down. So we can configure the interface parameters. And interface, we need to activate system interface, no shutdown. So it's already, you don't activate LDP on the interface. So we activate on the other interfaces, interface parameters, interface to P2, no shutdown. Then we need interface to P3, no shutdown. So you can verify the MPLS configuration. We have activated the two interface to P2 and interface to P3. Show router MPLS, show router LDP interface. You have these interfaces. The transport address, it's using the system interface IP. So these are the LDP configurations on P1. We move to P2, we do the same. So it is under LDP, interface parameters, interface to P1, it's now shut down. Interface interface to P3, no shutdown, info. So these are the interface, the LDP configurations on this router. Finally, on R3 exit, we need to be under the LDP configuration view. We do interface to P1, interface to P1, no shutdown, interface parameters, interface to P2, no shutdown. So we can verify our LDP configurations. So we have finished configuring LDP on these routers. The next is to verify that we have LDP session between these different routers. So starting with R1, I can run the command show router LDP session. You can see that we have two sessions on this router. We have 2.2.2 and 3.3. So it has established sessions to the neighboring routers. You can see that the state is established. On R2, we can do the same. We expect two sessions to show router LDP session. We have two sessions to P1 and P3. On P3, we also expect two sessions. So show router LDP session, we have two sessions to P1 and P2. So up to this stage, we have configured interfaces, we have configured OSPF, we have configured MPLS, and we have finished configuring LDP. The next stage is to now configure the service distribution points. So those are like the tunnels, the transport tunnels between the different PEs. So in this setup, we have three routers. We have P1, P2, and P3. We'll be configuring SDPs, the service distribution point from each router to the other. So we'll do a service distribution point from P1 to P2 and P1 to P3. On P2, we'll do a distribution point from P2 to P1 and P2 to P3. On P3, we also configure service distribution point from P3 to P2 and P3 to P1. So we're establishing a meshed kind of service distribution point between these different routers so that we have communication for our sites. So for SDP, the service distribution points, we have to be in the service configuration level. So we'll do configure service. This is where we configure the SDPs. If you display info, you can see that we have a default customer called customer 1. So you need to create a customer. In this case, we'll just continue using customer 1. We don't need to configure another different customer for our VPLS configurations. So for the SDPs, I have mentioned that we are configuring. So let's start with R1 first. Exit. So it's configure service. You can check info. So we need SDP. This is the service distribution point, kind of the tunnel that we are, the transport tunnel that we are building for our layer 2 service. So with SDP, you need to give it an ID and specify that we are configuring an MPLS SDP. So we are on router 1, so I will use the SDP to router 2, I will call it 102 and specify that it's an MPLS SDP. Can use a question mark. You have other parameter that you can configure. This is an MPLS and you have to add the command to create. So we are creating an SDP. One thing that you need to always configure is the far end IP. So this is an SDP to router 2. So we need to specify the far end IP as 2.2.2, the system IP of router 2. And then we need to now shut down. And finally, we can give it a description, maybe SDP to PE02. And we need to configure the signaling protocol. So we are using LDP. So that is it for SDP to router 2 configuration, that is to PE2. And we need to also configure another SDP to PE3. So in our service configuration, you can see that we have SDP 102. For another SDP 103. This is SDP from P1 to P3. I will use the same MPLS create, and we need to specify the far end. So the far end will be to 3.3.3. We need to give it a description SDP to PE03, and we need to give it the signaling protocol LDP and run the command no shutdown. So info, you have your configuration there. So we have two SDPs configured, SDP101, 102, and SDP103. So if you now show service SDP, you can see that our SDP are down because we also need to configure, to do similar configuration on R2 and R3, then our SDPs will be up. You can see the MPLS and the signaling protocol is targeted LDP. So we'll do similar configuration on R2. Exit, I've mentioned that we need to be in the service configuration hierarchy, configure service info. We'll have customer 1 created. So at this stage, we can do SDP. We are on P2, so it will be 101 towards P1, MPLS create. We give it a far end of 1.1.1. We need to give it a description SDP to PE01 and give it the signaling protocol of LDP. So you can use SRISIS, you can use BGP, you can use segment routing, whichever protocol you have configured in your underlay network. So we need to now shut down the SDP. You can see we have this configuration. So we need another SDP from P2 to P3. I will do SDP 103. We already have 103 on the other router. So from here we can do, you can use the same 103 and then MPLS create, and we need to specify let's undo shutdown. We need to first configure the far end, so this will be 3.3 and then no shutdown. We are still using LDP. We give it a description to PE03. So this is SDP to PE03 info. So you have your configurations for this SDP. We can verify our two SDPs. So we have SDP101 and SDP103. So up to this stage, we have finished configuring SDP on P2. We proceed to P3. So under the service SDP, we have 1 to P1 MPLS create. So the SDP ID will be locally significant, so that's why we are able to reuse the same, but we can verify once we do the service configuration for the VPLS. So we need to give it a far end of 1.1.1, no shutdown, and then give it LDP as the signaling protocol. Give it a description SDP to PE01, exit info. We also need to configure another SDP to 102. It's still MPLS create. Then we give far end of 2.2.2. We give it a description SDP to PE02 and then the signaling protocol of LDP. Finally, no shutdown, exit. So these are the SDP's configurations on P1. So if we go back to P1, remember our sessions were down. You can run the same command and now you can see that we have SDPs up. So you can show SDP 101. You will get more details about it. You can do detail and you can see much more detail about it, the operation, MTU, SDP source, SDP ID, the far end, and many other details, especially when you are troubleshooting. Maybe the SDP is failing to come up, you can always check more details about the configured parameters. So our SDPs are up. We can verify on R2, show service SDP. We have SDPs to 101, 103, and finally on R3, show system, show service SDP. We have 2 SDPs and the operation status is up. So at this stage, we can now go ahead and configure our VPLS, the point to multi-point connection for our VPLS service. So we'll start from R1. For VPLS configuration, of course, we need to do to bind the interface, we need to bind the SDP. Remember, we are using the service distribution point. So we need to use the service distribution point that we have configured before and bind them on our VPLS configurations. So we'll start with configuring P1. For P1, we'll create an ePipe. So we'll be creating an ePipe 200, and we'll still use the VLAN 200 as our customer-facing VLAN. And then on the customer side, we'll configure a sub-interface with VLAN 200. So for the VPLS configure service, remember we mentioned it's a VPLS, and then you need to give it service ID. So I've mentioned we are using 200, and then of course we need to specify the customer. So it's customer 1. We are using the default customer. Let me just recall this command: configure service VPLS, the Virtual Private LAN Service, 200 customer 1. And then you enter the command create, customer 1 create info. So it's shut down. We need to now shut down the VPLS. And at this stage, we can start by binding the SAP, the service access point. So this is the port that is pointing to the customer, and we are using the same VLAN 200. So if I show system LLDP neighbor to verify the port, you can see we have C3 connecting to site 1. So I will configure the SAP. This is the port. The VLAN is 200. And then I need to create no shutdown, valid port encapsulation. So we need to configure the port encapsulation first. Remember, this is currently it's a network port. So we need to configure it as a hybrid port to allow us to, an access port to allow us to tag the VLAN. So I will use the command configure port. We do the same on other routers. Configure port 11 shutdown, then configure port. We need Ethernet mode hybrid. We make it access, just make it access. And then Ethernet encapsulation type, we are making it .eq. Then we need to unshut the port. So we now shut down the port. Then configure service VPLS 200. We can copy the same command. This was the command that we need. So it's now okay. Info, you can see the SAP is bind to the VPLS. And then we need to configure the SDP. So in this case, we'll be binding to SDPs. Remember, we are creating a meshed topology. So we'll be configuring meshed SDPs from P1 to P2 to P3. So we can run the command mesh SDP, and then we have 2 SDPs. We have 10. We have 2. Let me show the SDPs first. Show service SDP. We have 102 and 103. So I'll start with mesh SDP 102, and then you enter the service that we have configured, create. info, no shutdown already. So we need to do the same for 103. So I will just recall the same command, info, no shutdown, exit, info. So we have the mesh SDP configured from P1 to P2 and P1 to P3. So these are the configuration that we need for SDP configurations on P1. We'll do the same on P2. So on P2, we are already in the configure service, so it's VPLS 200, customer 1, create. And then we need to assign the SAP, show system LLDP neighbor, to verify the port. So we can do SAP. The SAP to site 2 is this one. VLAN it's 200, create. We first need to change, what I'll do is no shutdown, and then we need to change the port to access. So sometimes when you are in this hierarchy, you can use the backslash and it will allow you to do the configurations. So it's configure port, this port shut down, and then configure this port Ethernet the same way we did on the other router. So it's Ethernet, let me expand it. Ethernet mode, we make it access, and then Ethernet encapsulation type, it's .eq, and we enable the port. So we are able to continue with our configuration. So I'll do port, now we need the service access point. So it's service access point, this port, VLAN 200, create, no shutdown, info. We have the service access point. We'll show system, show service SDP, just to get the IDs. So we need to configure the meshed SDP. So I will do mesh SDP and then 101 200 create, no shutdown. Then we have 103 info. So these are the configuration that we need on P2 for the VPLS configuration. And finally on P3 we do the same, configure service, it's VPLS 200, customer 1, create, no shutdown, info. I'll use the backslash again, configure port, let me show system LLDP neighbor. So it's configure port, this is 11C3 shutdown, configure port 11C3, Ethernet mode, access, and then we need to configure the encapsulation type. We are using .eq. Then we need to enable the port again, so no shutdown. So we can configure the SAP. VLAN is 200, create, no shutdown, info. Then we need to configure the mesh SDP. So mesh SDP, if I run show service SDP, you can see that we have 101 and 102. So at this stage, mesh SDP 101, VLAN is 200, create, exit. We need to do the same for 102, create, exit, info. So we have configured the two mesh SDPs. So these are the configuration for the VPLS. We can now test our VPLS to see if we can be able to ping the VPLS. So you can run the command show service ID 200 base. You can see that the service is up, admin MTU, the operation MTU, the admin status, the operation status, it's all up. On R1, show service ID 200 base, same, you can see that we have the details. On R3, on R2, show service ID 200 base, you have your status for the VPLS. You can also display all and you'll be able to get much more detail about the VPLS. So up to this stage, we can try to ping our VPLS. So you can use, so show service ID 200 base. You can see that this is the service. We can use the command O&M VCC ping and ping this SDP. Maybe count of 5. You can see that we are able to ping. We can do another ping for 103. And we are able to ping. We can do similar test on R3. Exit O&M using the command O&M VCC ping 101 200 count 2. We are able to ping. Can try 2. We are able to ping. And finally on R1, exit. So same command O&M VCC ping 102 200 and 103 200. So you can see that we are able to ping. So our VPLS is up. We now have to go ahead and do the final configuration. So we'll be configuring an interface on site 1, site 2, and site 3, and try to ping between the sites to ensure that we have connectivity between the different sites. So we'll start with R4. So I need to log into R4. This is R4. So on R4, show system LLDP neighbor, you can see that we have a connection to P1. I need to configure the port first. Remember, currently it's a network port. We need to configure it as a hybrid port so that it allows us to configure the VLAN, to tag the VLAN, and also to assign IP address. So I will configure port, this port, shut down. And then we can do Ethernet mode hybrid Ethernet encapsulation type .eq, and then we need to enable the port again, so it's now shut down. So we'll configure router interface, I just name it to VPLS. I will assign a port of this one, VLAN is 200, and then I'll give it an address of 172.100.100. From the topology, you can see the IP address assigned is .1. .1 mask is 24. Info. Show router interface. You have the interface configuration. So we'll do the similar configuration on R5. We need to first configure the port. So it's configure port. We'll first show system LLDP neighbor. Configure port. This port, shut down. Recall the same command, configure port, Ethernet mode. This is how we change the mode to hybrid. And then we need to encapsulation type .eq. We have configured the port, configure router interface to VPLS. and we need to assign the port. So the port is 11C1, VLAN is 200, and then we need to give it an address of 172.100.100.2. Let's verify the IP address. It's .2, it's 24 info. So these are the interface configuration. And finally, we need to configure our R6. So I will log into R6, configure port. No, let me first get the port. Show system LLDP neighbor, configure port. This is the port. Shut down first. So before you change the mode, you always have to shut down the port, and then you can change Ethernet mode. So we have option of access network hybrid, so we'll go with hybrid as usual. And then encapsulation mode, it's .eq. You could be having the Q and Q null. We'll demonstrate how to configure the Q and Q later. For now, we'll just use .eq, and then you can enable the port again. Now shut down. So configure router interface to VPLS port. We are binding the port. VLAN is 200, and finally we assign an address of 172.100.100.3. mask is 24. So we have configured our interfaces. We can start to test our service. So on P1, show router interface. Now I need to R4, show router interface. We have this interface. I can show router ARP. We only have this one IP. Let's try to ping 172.100.100.1 with the local IP. .2. We are not able to ping. We'll troubleshoot that. .3 we are able to ping. So we are able to ping from site 1 to site 3. Info, that is mask 24. Exit. Let's try to check why we are not able to ping from. But first we need to ping from R5. R5 we have an IP of .2, so we can try to ping first. Show router ARP. We only have the local interface. Ping 172.100.100.1. We are not able to ping. Try to ping .3. We are not able to ping. So it seems there is an issue with the site 2. Show system LLDP neighbor. Did I shut down the port? Show port. So the port is still shut down. That's why we are not able to ping. So it's configure port. When we are changing the mode, and then we didn't unshut the port, so it's now shut down. Show system LLDP neighbor. We have the connection. So let's go back to R4. R4, try to ping .3.3. We are able to, and then site 1, try to ping .2. We are able to. Show router ARP all. Show router ARP. You can see that we are able to learn the MAC addresses from the far end. So this is a kind of a switch. Remember, VPLS for the customer is kind of a switch, is connecting to a switch. So that's why we are able to learn the MAC address from the remote sites. So on R5, remember we were not able to ping. We can show router interface. Then try to ping 172.100.100.1. We can ping. Then .3. We can also ping show router ARP. We have the 3 MAC addresses from the far end devices. Finally, on R6, we can ping 172.100.100.1. We are able to ping this is on R3. We are able to ping show router ARP all, show router ARP. So this is it, guys. This is how you configure VPLS on Nokia routing devices. Remember, we started by configuring OSPF for reachability, and then we configured the service distribution points, we configured MPLS, we configured LDP, and after that we configured the service distribution point, and then we went ahead and configured the VPLS. So it's very easy to implement VPLS on Nokia routing devices. We'll just take a recap of the configuration. Configure router, we did the configuration for the interfaces, and then we configured OSPF, we configured MPLS, we configured LDP down here. And after LDP configuration, we now went ahead and configure service info. So for the service configuration, we first configure the service distribution point meshed. Remember, we are configuring to both PEs, and then we did our VPLS configuration, the Virtual Private Lan Service configuration. So this is it, guys. I hope you have enjoyed the session. If you have any challenges implementing VPLS on your lab, feel free to ping me up, and you can leave your comment in our comment section. If you have enjoyed the session, again, please remember to subscribe to our channel and to support us. Thank you for watching, and see you in our next episode. Bye.